Okay, so today what we're going to talk about are applications with exponential functions. All right, so the first thing we're going to talk about is compound interest. So this should be familiar from last year from Algebra 2. So we have A is equal to P times 1 plus R over N raised to the NT power. A is your final amount, so that's the balance in the account. P is the principal, that's what your investment. R is your rate. Your rate has to be expressed as a decimal, not as a percent. N is the number of times it's compounded per year. And T is the number of years. So let's take a look at number 1. Or the first example. Michael deposits $500 in an account that pays 5% interest compounded quarterly. How much will he have in the account after 5 years? 15 years. So we're going to let's write down the formula. A equals P times 1 plus R over N raised to the NT power. All right, so I want to know how much is in the account, so that's what I'm looking for. I'm solving for A. P is your investment, which is 500, times 1 plus your rate. Now, your rate, the percent is your interest rate. You want to represent that as a rate, which you move the decimal 2 places to the left, which would be 0.05. So it'll be 0.05 over N. That's the number of times it's compounded. It's compounded quarterly. Quarterly would be 4 times a year. I think quarterly, 4. Raised to the 4 times T, which is how many years it's being in the bank, which is 15. So that you could just plug in your calculator all at one time. And after 15 years, $500 will become $1,053.59. Okay, so let's look at compounded continuously. So compounded continuously, that formula is A equals PE to the RT. So same thing, P is your investment, E, remember, is a natural base. So that's a constant already. R is your rate, T is time. All right, so it says, you only use this when it says compounded continuously. So a total of $15,000 is invested in an account, is invested at an annual interest rate of 9%. Find the balance after 5 years if it is compounded continuously. So I have A equals my principal, which is what's my investment, $15,000, times E, raised to the RT power. So my percent as a rate would be 0.09. So it'd be 0.09 times 5, because we're leaving it in the account for 5 years. So that you could just plug in your calculator all at one time. You get $23,000, $524.68. Okay, so flip it over. Okay, so the next thing we're going to talk about is population growth or decay here. So population growth or decay. So it would be growth if it's plus in here. Decay would be a minus. So it's A equals I times 1 plus minus R raised to the T power. A would be the final amount. I would be the initial population. So you could use a P for that too. R is the rate, obviously expressed as decimal. T is time in years. Okay, so let's take a look at the first one. So it says a town had a population of 27,000 in the year 2000. It is increasing at a rate of 2.5% each year. Find the year the population will be $50,000. All right, so you're going to have to use your calculator for this. All right, so this is what I know. A equals, the initial population we're talking about is 27,000 in the year 2000, times 1 plus 0.025, that's my rate, raised to the T power. So I want my A to equal 50,000 because I'm looking for how many years. So what you're going to do is you're going to graph both of these. So in your calculator, graph, so this would be Y1 and this would be Y2. So you're going to graph this. And when you graph Y equals 27,000 times 1.025 to the T power, it looks like this. You're going to have to change your scale. So I would change this to 30, the x-axis. and I would make the y-axis 60,000. That should make sense because I now have to plug in y equals 50,000. So here's 50,000. So I want to know when my population will reach 50,000, which would be right here. I'm looking for this time here. So graph both, find the intersection, and this comes out to be 24.95 years, which is about 25 years. You got to round that up because you can't round it down, it won't be enough. So in what year? It says find the year. That it will take 25 years. So I'm starting off at 2000. So it'll be 2000 plus 25. So in the year 2025, the population will be 50,000. All right, let's talk about radioactive decay. Radioactive decay is half-life of a radioactive substance is the amount of time it takes for half the substance to decay. So you should remember this from last year. So it's f of t is equal to s times 1/2 raised to the t over h power. F of t is the amount of substance that remains. S is the initial mass. H is the half-life, and t is time. The half-life of a radioactive element is 25 years. The initial mass is 10 grams. Write an equation of the exponential function that models the radioactive decay of the element. Okay, so this is A. So my function would be f of t equals, so S is my initial mass, which is 10 grams, times 1 over 2 raised to the t over h is your half-life, which is 25 years. So it'll be t over 25. Okay, B. How many grams of substance remains after 40 years? So that means I'm looking for F of 40. So 10 times 1/2 raised to the 40 over 25 power. So that you could just plug into your calculator. And we get F of 40 is equal to 3.298769777 grams. That's how much will be left. All right, C. How long will it take to have less than 1 gram left? So you're going to use your calculator. Okay, so you're going to graph both. I'm just going to move everything up a little bit more. So you're going to graph both. And when you graph your exponential, it looks like this. So you're going to have to change your x-axis, make this 100. And your y-axis, you can make that 20. And then you're going to graph. So we graphed f of t, is equal to 10 times 1/2 raised to the t over 25. And I want to know when I will have less than 1 left. So graph 1. Okay, so I will have less than 1 here. So I want to find this x value. So do intersect. This 83.04 is a little bit more. So when it's less than 83.04. 83.04 years. Okay, so that's it. Have a good night.